Let's look at another situation in which we are looking for the connection or association between two categorical data variables. Notice at the top of the page here we have a picture of a coral reef in the ocean, and then to the right we have a two-way table that gives us some numbers around healthy or unhealthy coral versus low nitrate concentration and high nitrate concentrations. Let's read a little bit about this. The two-way table displays data about 55 different locations. Scientists have a list of possible chemicals that may influence the health of the coral. They first look at how nitrate concentration might be related to coral health. The table displays the health of the coral, healthy or unhealthy, and nitrate concentration, low or high. A. Complete the two-way relative frequency table for the data in the two-way table in which the relative frequencies are based on the total for each column. Okay, so there's a lot to listen to there, but let's just talk a little bit about what we have here. So first off, we're looking at the relative frequency is based on the total for each column. That's key here because we're going to be analyzing the totals from the columns here when we are looking at the percentages. So the columns here are the low nitrate concentration and the high nitrate concentration. And the total for the low nitrate concentration is 28, and the total for the high nitrate concentration is 27. All right, so now let's go ahead and come up with the percentages. So we have the actual numbers for the 55 locations in the two-way table. And then we're going to be interested in what percent that is out of 55 for the columns. Okay. So the first one is low nitrate concentration and healthy. So this first one here. So we're going to be thinking about our total of 28 low nitrate concentration locations. All right, that's what we're taking it from. And then we are looking at how many of them are healthy versus unhealthy. So if we look at the healthy amount, then that would be 20 out of those 28 that are healthy and have low nitrate concentrations. All right, so 20 divided by 28. So this is where we need to use the calculator and come up with a percentage. So 20 divided by 28 is 0.714 with a number of numbers after the decimal point. So if we're rounding that to the nearest hundredths place so that we can convert it to a percent, it looks like 0.71. Okay, so that's approximately. So we'll use a little squiggly equal sign there to represent approximately 0.71. And that is, if you multiply it by 100 or move the decimal point over 2 spots, that is 71%. All right. And if we look at the unhealthy, all right, we are still taking it out of that total of 28. Again, because we're basing it on the columns here. There are 28 total low nitrate concentration locations, and 8 of them were unhealthy. All right, so 8 out of 28, and this should just be the amount that gets us up to 100%, but let's just verify that. So 8 divided by 28 is 0.2857. So if we're rounding that to the nearest hundredths place, that would actually be 0.29 because that 5 makes the 8 round up to a 9. So approximately 0.29 or 29 hundredths. And if we multiply that by 100 and move the decimal point over 2 spots to the right, then that would be 29%, which makes sense because 71% plus 29% does add up to that total of 100%. So where there was low nitrate concentration, 71% of them were healthy and 29% were unhealthy. All right, let's fill out the other column in the table, which is the high nitrate concentration. Let's use a different color. So the total for the high nitrate concentration was 27. So that's the denominator. That's what we're taking it out of when we're doing our fraction. So the denominator is 27 in both of these, right? because we're taking it out of a total of 27 high nitrate concentrations. And if we're looking at healthy versus unhealthy, well, let's start off with the healthy. So 5 of those high nitrate concentration locations were healthy. So 5 divided by 27. 5 divided by 27 is 0.1851, and that same 4 digits is repeating. So if we're rounding it to the nearest hundredths place, so 2 points after the decimal point, 2 places after the decimal point, that would be 0.19 or 19 hundredths. So it's approximately 0.19, which is equal to 19%. And then the unhealthy then should just be 81%, what gets us up to 100. Let's just double check that. So there are 22 that were unhealthy, and 22 divided by 27 is 0.814. And so yes, if we round that to the hundredths place, it's approximately 0.81, which is 81%, which makes sense because 19% plus 81% does get us up to 100%. So since we were analyzing the relative frequency tables based on the total in each column, it's the column numbers that were the denominators for each one of our fractions and percentages. Okay, so let's answer the questions. When there is a low nitrate concentration, which had a higher relative frequency, healthy or unhealthy coral? So I want to highlight here what we are looking at. So it says when there is a low nitrate concentration. So we are looking at the low nitrate concentration column, which had a higher relative frequency, healthy or unhealthy. So the higher percentage in the low nitrate concentration was that 71%. So in the low nitrate concentration locations, 71% of the locations had healthy coral. Okay. Part C. When there is a high nitrate concentration, is there a higher relative frequency of healthy or unhealthy coral? So notice, once again, this time we're designating the high nitrate concentration as the focus, which means we're looking at the high nitrate concentration column. Which one had a higher relative frequency? In other words, a higher percentage. So in this case, that 81% in the unhealthy was the higher percentage. So in that case, 81% of locations had unhealthy coral. So that's how we might interpret those. So based on the data, is there a possible association between coral health and the level of nitrate concentration? All right, remember, we're talking about a connection. So when we say possible association, we're talking about, is there a connection? Is there a relationship between the nitrate concentration and how healthy the coral will be? Well, there certainly seems to be in this case, in two different ways. Let's look at the low nitrate situation first. So with the low nitrate concentration, there is a much higher percentage in one than the other, right? 71% of the locations had healthy coral. It's not 50-50. It's not like it doesn't matter if there's low nitrate concentrations. We had some healthy, we had some unhealthy. No, there's a pretty large percentage that were healthy. And so then if we compare it, what happens with high nitrate concentrations? Do we still see a bunch of healthy coral? No, actually in reverse of that, right? We actually see high nitrate concentrations in which the unhealthy locations are a much higher percentage. So let's add that to our association. Also, with high nitrate concentrations, (81% of locations had unhealthy coral. So based on that, I think it seems pretty clear, because we've looked at it from two different directions, that the nitrate concentration does seem to have a relationship or a connection or an association with the coral health. So let's add that. So nitrate concentration seems to have an association with coral health. That's just looking at the data. There seems to be a connection there. I'm not exactly sure why there is a connection, but there seems to be a connection. Now there is another part to this problem here, so let's just go on to the next page. The scientists next look at how silicon dioxide concentration might be related to coral health. The relative frequencies based on the total for each column are shown in the table. So I'm going to highlight that again, the total for each column. So again, we're talking about those concentrations, this time of high silicon dioxide. Based on this data, is there a possible association between the coral health and the level of silicon dioxide concentration? Explain your reasoning. Okay, so this time we have the percentages already. Now, if we look at low silicon dioxide concentration, notice there's 44% that is healthy and 56% unhealthy. So at first it might look like, okay, well, there's a little bit higher percentage of unhealthy when there is a low silicon dioxide concentration. But then if we switch over to high silicon dioxide concentrations, does that percentage change? Do we see a difference there? We really don't, do we? 46, 54%, that's almost the same numbers as the first column with the low silicon dioxide concentration. So in this case, it doesn't seem like there's a strong connection or association between the silicon dioxide concentrations and how healthy or unhealthy the coral is, because it's pretty much the same whether it's low concentration or a high concentration. So let's say that. So it doesn't seem associated. Since both, I don't really need the calculator anymore here, let me just get some room to write. Since both low and high silicon dioxide concentrations have about the same percentage of healthy and unhealthy coral. So when we compare the two, there just doesn't really seem to be a connection. There's not a big change between the healthy and unhealthy coral depending on low silicon dioxide or high silicon dioxide concentrations.